Alright guys, we're going to go over the independent practice, which was on page 269, 270. We're going to go over problems 1 through 11 odd. And so if you did it right, here are the answers. You can check how you did. Number 1 is 15, number 3 is 2, number 5 is 4 and 2/5, number 7 is 2 and 2/5, number 9 is 24, and number 11 is 7th grade. Keep in mind, these are all mixed numbers. I don't want to see any improper fractions on the quiz, just a quick reminder. Let's get to it. Alright, multiply, then write in simplest form. Again, I'm going to copy down the problem correctly. Make sure I copy it down correctly. I have 20 times 3/4. Okay, I'm going to go kind of fast. I have a whole number times a fraction. My answer is going to be less than 20. Why? Because it's not 1. This is less than 1 by definition. It's a fraction. It's part of a whole. Okay? Anyways, 20 over 1 times 3 over 4, 60 over 4. And if you divide 60 by 4, you're going to get 15. Again, if you do the math, I'll let you try it out, verify that it's 15. I could be lying to you, but I'm not. It is actually 15. Number 3, 10 times a fifth. Okay, we have a whole number times a fraction. With the first two problems, actually, think about it. Maybe we have 10 full sets of something, and we're breaking it down. We're breaking it up into pieces. Okay? Kind of like dividing, but not necessarily, because we're not losing anything. You're just sorting it out into different groups, if you will. Okay? So 10 over 1 times 1 over 5. The answer is 2 for that one. It can be that easy, guys. Don't overthink it. Change the whole number to a fraction, put a 100. Numerator times numerator, denominator times denominator. You get a fraction problem, which is a division problem. You get a fraction, which is a division problem, and it's 2. All right, number 5. Now we have a fraction times a whole number. The order doesn't matter. You can do 11 times 2/5. But think of the idea. Here we have a fraction times a whole number. So we have part of a set, and maybe we're trying to complete the set. And so we're asking how many complete sets do we have if you multiply this 11 times, right? You can do an area model if you want to verify, but I'm going to go ahead and stick with the equation. 2/5 times 11 over 1. Four full sets. And like I said before, look at the denominator. We started with sets of 5, we ended with sets of 5. Unless you simplify, that doesn't change. Okay? 2/5 times 11. Look at our whole number is 4. We have 4 full sets. Much less than we started with, which was 11 full sets. Okay? Anyways, let's keep going. Number 7. The male Cuban tree frog is 2/5 the size of the female Cuban tree frog. The average size of the female Cuban tree frog is shown at the right. What is the size of the male? All right. Again, if you have your book out in front of you, or the page, the female frog is 6 inches long. All right, so look what I'm going to do. I'm not going to draw a frog. I mean, I'm not. I'm just not even. But I can draw a bar to signify that. So here we have a female frog, a female bar, 6 inches long. Okay, but half a foot. The male frog is 2/5 of that. 1, 2, 3, 4, 5. Yeah. So if we were to take this frog and divide it up into 5 parts, okay, I know it's a little gross, but not pretend. In our mind, we're dividing that frog into 5 parts. The male frog would only be 2 parts out of the 5. Okay. So this would be the male frog. The whole thing would be the female frog. Okay. Another way to look at it, if you want. If you were to cut this, if this was 1 inch, for every 1 inch, if it's 5 parts, 2 parts of that would belong to the male frog. That means 3, right? So when you think of it that way. 2 parts out of every 5 inches, right, belong to the male frog. Yes? Again, if you were to take that inch and divide it into 5 parts, 2 of it would be for the male frog. But we have 6 inches, right? So, kind of skipped a step, that's okay. Numerator times numerator, denominator times denominator. 2 times 6 is 12. 5 times 1 is 5. Okay. You're making sets of 5, but you have 12. You can make 2 sets of 5 out of 12. That leaves us with 10. Remainder of 2. 2 out of 5. Again, denominator, denominator. Look at the denominator. That tells you a lot. You need to know what the denominator is as soon as you get a chance. So the frog is only 2 full inches and 2/5 of another inch. Okay? Almost 3 times the size. Okay? All right, let's carry on. Number 9. One evening, 2/3 of Mrs. Thorne's students watched the reality television show. Of Miss Lombardo's students, 4/5 watched the same reality show. Which teacher had more students that watched the reality show? All right, let's break this down. You don't have to draw pictures of things. You can write words. You can write ideas that'll help you understand the problem. So we're talking about 2 teachers. Mrs. Thorne and Mrs. Lombardo. All right, you gotta look at this little table. So Mrs. Thorne has 36 students, Mrs. Lombardo has 30. So 36 students for Mrs. Thorne, 30 students for Mrs. Lombardo. So what's the deal here? What's the problem? What's going on? So we have 2 teachers with classrooms full of students. She has 36, she has 30. And apparently there's this survival TV show, reality show. I don't know why I said survival, but it's a TV show, a reality show. You guys know what that is. And the question is, which class had more students that watched it? Okay? Same TV show, 2 different classes. How many students watched it in each class and who had more? Basically, which class had more students watching it? All right. So 36 students, 30 students. Of the 36 in Mrs. Thorne's class, 2/3 watched it. So for every 3 students, 2 watched the TV show. That's a lot. It's almost 1. For 30, for Miss Lombardo, excuse me, her class, 4/5. For every 5 students, 4 watched the show. Now, you could estimate, say, well, this is close to 1, that's close to 1. And since Mrs. Thorne has more students, that means that Mrs. Thorne had more students that watched the show. You might be right, you might be wrong. We're not estimating here. Actually, you have to do the work. Okay? Again, for every 3 students, 2 watched the show, right? Okay. What's 36 times 2? 72. 3 times 1 is 3. If you divide this, I know it's not showing you the work completely, but I've been doing this long enough where you can do it in your head. You just know the answer already. So what does that 24 mean? That means that out of 36 students, 24 watched the show. 24 students watched the show. All right, now 30 times, I'm going to skip a couple steps. 30 times 4 is 120 over 5. I can make 2 groups of 5 out of 12, excuse me, 10. 12 minus 10 is 2, bring down to 0. I can make 4 groups of 5. And there we go. 24 students. So if both classes had 24 students that actually watched the show, it's a tie. Neither class won. That's why neither class won. Neither class had more students watching the show. Okay? And that's number 9. Guys, seriously, don't assume anything. It helps if you stay organized. Write words, draw pictures. Make sure you understand what's going on. In this case, we have 36 whole students. We multiplied it by a fraction because we're trying to break these students into groups. We're breaking the students up into groups. It sounds like division, and maybe it is, but we're not losing anybody, okay? 24 students. It's not like all of a sudden the other students that are left disappeared. They're still there. So 24 students watched the show, 12 didn't, right? The students are still there. We still have 36 students. They've just been broken up into groups according to this fraction, okay? Keep that in mind. Which leads us to number 11. sorry you had to see this. Not the most exciting part of the notes, but there you go, number 11. Who did it in pencil? Pen. Should do it in math and pen. Right, number 11, almost there. It's another word problem. Students at Marzo Middle School were recently surveyed. The results reported that 1/4 of 6th grade students, 3/10 of 7th grade students, and 2/7 of 8th grade students plan a career in STEM. Which grade did the most students plan to have careers in STEM? All right, if you don't know what STEM means, that means science, technology, engineering, and math. The question is asking, in this middle school with 3 grades, 6th, 7th, and 8th, which grade had more students that wanted to become scientists or engineers or get involved in some kind of technology or math even, right? Now, according to this little table, I'm looking at the table it has right there. In 6th grade, there are 152 students total. That's everybody. 7th grade, 160 students. 8th grade, 147 students. But again, we're looking at a fraction. We're taking this full set and we're breaking it up into groups. Okay? Not all of them want to go into math. According to this, it's 1/4. For every 4 students, only 1 person out of those 4 wants to become a scientist or engineer or mathematician or some kind of person in technology. Okay? I'm kind of going ahead a little bit. For 7th grade, we have 3/10. For every 10 students, 3 want to go into STEM. And for 8th grade, it is 2/7. Again, don't assume that, just because 7th grade has the most students, that it'll be the one with the most STEM students. It might, but don't assume. Do the work. Okay? Again, this is pretty close to 0. This is close to 0. This is closer to 0. Wow, it actually might be this. But again, that's just a guess. Let's find out. Let's verify. Okay, let's do the math. Again, benchmark fractions, 0, half, 1, and all that. That was the last lesson. Let's just go ahead and do the work. 152 over 4. 480 over 10. 202 times 7 is 14. 2 9. 2 times... Okay, granted I did this in my head, but basically numerator times numerator, denominator times denominator, and so forth. Okay, I'm going to do some division here. .38 students. So let's, I know I went kind of fast, but out of 152 students, only 38 want to do STEM. That makes sense, 1 out of 4, right? You'd end up dividing this by 4. You break this up into 4 groups, that means each group has 38. Only want one of those groups, and that's why the answer is what it is. All right. Now, quick trick, I can cross out the zeros. 48 divided by 1. What did I just do there? I divided by 10, basically. Oh, look at that. If it ends in 0, I can divide by 10. I have 48 over 1. 48 divided by 1 is 48 students. So 7th grade has 48 students, right? This one, there is no real trick that I can think of. I'm just going to go ahead and do the math. I can make 4 groups of 7 to get 28. This one has 42 students. All right, well, we got lucky. Turns out 7th grade did have the most STEM students. So the answer is 7th grade. 7th grade had the most students. For STEM.